My name is Greg Mobley, and this is my presentation on RF antennas. So what is an RF antenna? RF antennas use electromagnetic waves to transmit information across distances. We learned that electrons create electric fields and currents create magnetic fields. And so the way an RF antenna transmits is that on its elements, it uses voltage potential differences and currents to create an electromagnetic wave in free space. This wave is able to move through free space because of the interaction between electric and magnetic fields. That being that as the electric field oscillates in its direction of travel, it creates a magnetic field oscillating in the same direction of travel. And that magnetic field also then induces an electric field in the same direction of travel. So because of this interaction between them, how the electric field kind of feeds the magnetic field and vice versa, the electromagnetic wave is able to travel over distances. And of course, the electric field and the magnetic field we learned are normal both to each other and to the direction of travel. So polarization, we learned that polarization is kind of the shape an electromagnetic field draws as seen through the plane of the direction of travel, kind of like looking through a window. Electromagnetic fields can be linearly, spherically, or elliptically polarized, or not polarized at all. So just as we saw in the previous slide, how voltage potentials and currents can create electromagnetic waves, the same thing works in reverse. And when that electromagnetic wave touches a conductor, that being the receiving antenna, the electromagnetic field induces a current in that receiving antenna. And this current is optimized when the polarization of the electromagnetic wave matches the polarization of the receive antenna. For example, if you have a linearly polarized vertical wave and a horizontally polarized um, antenna, linear, the 90-degree phase shifts would result in zero power being transferred. So this is something to keep in mind, that the polarization on the transmit side has to match the polarization on the receive side to optimize efficiency and make sure that you have the most current possible on the receive side of your antenna. Something else that has to be kept in mind are losses. So we learned that due to the inverse square law, both electric and magnetic fields lose energy as they move away from the source. So this is energy that's lost that has to be accounted for, and nothing can really be done about it. You can also have obstructions, which could be buildings or trees or anything in the path of your electromagnetic wave. We learned that when electromagnetic waves hit a different medium, part of that wave is reflected and part of it is refracted. And the part of that wave that continues forward, the refracted part, has a fraction of the power of the original wave. So this is important to keep in mind, because when you're designing a system, you have to make sure that your receive antenna is sensitive enough to pick up that wave that's been greatly reduced. That way, once the electromagnetic wave is received and processed on the distant end, you have enough energy left to effectively transmit the information that's trying to be shared. And that's all for my presentation. Thank you.